Throughout the annals of human history, storms have swept across the earth with a force that both terrifies and fascinates us. Towering walls of wind and rain, spiraling vortexes of destruction, and relentless surges of water have left indelible marks on landscapes and lives. Today, we embark on a journey into the heart of nature's fury, exploring the 5 strongest storms ever recorded. A testament to the raw power and mysterious beauty of our planet's atmosphere. Each storm is more than just a weather event. It is a complex interplay of scientific factors, a chapter in the story of our planet, and a moment that forever changed the course of communities, ecosystems, and entire nations. Let's dive into the epic saga of storms, beginning with the super typhoon that stunned the world, and ending with a hurricane whose legacy still shapes climate science today. Number 5. Hurricane Katrina, USA 2005. In late August 2005, the Gulf Coast of the United States found itself under siege by a behemoth. Hurricane Katrina was born as a tropical depression over the Bahamas, a swirling mass of warm, moist air that fed on the heated waters of the Atlantic. As it moved westward, Katrina gathered strength, transforming into a Category 5 monster, the highest rating on the Saffir-Simpson scale. What made Katrina so devastating was not just its wind speeds, which peaked at 175 miles per hour, or its immense size, but the perfect storm of scientific and human factors that collided in its path. The storm's eye slammed into Louisiana, Mississippi, and Alabama, bringing with it a storm surge that breached levees and inundated the iconic city of New Orleans. Streets became rivers. Homes vanished beneath water. Over 1,800 lives were lost, and entire neighborhoods were erased in a matter of hours. The environmental impact was staggering. Saltwater flooded coastal wetlands, killing thousands of animals and plants, disrupting ecosystems that had thrived for centuries. The economic damage soared above $125 billion, making Katrina the costliest natural disaster in U.S. history. In the aftermath, scientists and policymakers studied the intricate dance of atmospheric currents, ocean temperatures, and urban infrastructure, seeking lessons on how to forecast, prepare for, and mitigate such catastrophes in the future. Katrina's legacy is not just one of loss, but of resilience, a reminder that human ingenuity and community spirit can weather even the fiercest storm. Number 4. Cyclone Nargis, Myanmar, 2008. On the other side of the globe, in the Bay of Bengal, another storm was brewing. Cyclone Nargis began as a low-pressure system, slowly intensifying as it drew energy from the warm tropical seas. By May 2, 2008, it exploded into a Category 4 cyclone, unleashing winds of up to 135 miles per hour and a deadly storm surge. Myanmar, a nation largely unprepared for such a catastrophe, bore the brunt of Nargis's fury. The Irrawaddy Delta, a vast expanse of rice paddies and villages, was transformed overnight. Villages disappeared beneath the surging tides. Trees were ripped from the earth. More than 138,000 people perished, making Nargis one of the deadliest storms in recorded history. The environmental toll was equally severe. Saline water inundated fields, destroying crops and leaving over 2 million people without food or shelter. The delicate wetlands, home to myriad bird and fish species, were decimated, upsetting the ecological balance for years to come. Scientifically, Nargis highlighted the importance of storm forecasting and early warning systems. The lack of timely communication and evacuation plans amplified the disaster, underscoring the need for robust meteorological infrastructure and international cooperation in the face of increasingly violent storms, an issue that grows ever more urgent in our warming world. Number 3. Hurricane Harvey, USA 2017. Fast forward to August 2017. The world watched in awe and horror as Hurricane Harvey made landfall in Texas, USA. Harvey was unique, less for its wind speeds, which reached 130 miles per hour, and more for its relentless rainfall. For days, the storm hovered over Houston and surrounding areas, dumping more than 50 inches of rain in some places, shattering records and transforming highways into rivers. The flooding was catastrophic. Over 100,000 homes were damaged or destroyed. Tens of thousands of people were displaced. Economic losses soared to $125 billion, matching Katrina's devastation a decade earlier. The environmental aftermath included chemical spills, sewage overflows, and widespread contamination of water supplies. Harvey's legacy lies in its lesson about the changing nature of storms in a warming climate. As global temperatures rise, the atmosphere holds more moisture, leading to storms that are not only stronger but wetter. A new breed of hurricanes whose primary weapon is rainfall, not wind. Scientists now study Harvey as a model for understanding how climate change is reshaping the patterns and impacts of tropical storms worldwide. Number 2. Super Typhoon Haiyan, Philippines, 2013. November 8, 2013 dawned with ominous warnings for the Philippines. Super Typhoon Haiyan, known locally as Yolanda, was barreling toward the archipelago with unimaginable force. Winds topped out at 195 miles per hour at landfall, making Haiyan one of the strongest tropical cyclones ever recorded on Earth. The impact was swift and brutal. Coastal cities like Tacloban were flattened. Trees snapped like matchsticks. Entire communities vanished beneath walls of water that surged miles inland. Over 6,000 lives were lost, and millions were left homeless. Haiyan's scientific significance lies in its extraordinary intensity. Meteorologists studied the storm's rapid strengthening, uncovering the critical roles of sea surface temperatures, atmospheric instability, and low wind shear. The storm's unprecedented ferocity prompted renewed global conversations about disaster preparedness, climate resilience, and the urgent need to address global warming. Since warmer oceans are a key ingredient in the recipe for super typhoons, for the people of the Philippines, Haiyan was a national trauma, but also a call to action. Rebuilding efforts led to better warning systems, stronger shelters, and a greater emphasis on environmental stewardship, a testament to human tenacity in the face of nature's might. Number 1. The 1970 Pola Cyclone, Bangladesh, 1970. Before radar and satellites could track every swirl of cloud, the Indian subcontinent faced one of the deadliest storms in history. In November 1970, the Pola cyclone formed over the Bay of Bengal, fed by warm waters and favorable winds. As it approached Bangladesh, wind speeds reached 115 miles per hour, but it was the storm surge, a massive wall of water, that proved most lethal. Entire islands were submerged. Villages disappeared. More than 500,000 people lost their lives, making the Pola cyclone the single deadliest tropical storm ever recorded. The environmental damage was incalculable. Farmland was salted and ruined, rivers changed course, and coastal ecosystems were transformed overnight. The Pola cyclone's legacy is profound. The disaster sparked political upheaval, contributing to the independence movement that led to the birth of Bangladesh. It also highlighted the urgent need for better forecasting, international aid, and disaster management, lessons that reverberate to this day in the region's approach to storms and flooding. Storms, nature's unyielding power. What unites these 5 storms is not just their scale or devastation, but the way they reveal the secrets of our planet. From the swirling birth of a tropical cyclone to the heartbreaking aftermath, storms are natural laboratories, teaching us about atmospheric physics, ocean currents, and the delicate balance of the Earth's climate. The formation of a powerful storm begins with the sun's energy, heating vast expanses of ocean. Warm, moist air rises, creating low pressure and drawing in cooler air. As the system grows, it organizes into a spiraling vortex, a living engine of wind and water. Factors like sea surface temperature, wind shear, and humidity determine whether a storm will dissipate or explode into a super typhoon or hurricane. As climate change accelerates, the frequency and intensity of storms are increasing. Warmer oceans mean more fuel for cyclones. Shifting wind patterns alter storm tracks, putting new regions at risk. Scientists warn that the storms of the future may be even more powerful, unpredictable, and destructive. But with every storm comes progress. Advances in meteorology, like satellite monitoring, computer modeling, and early warning systems, save lives and help communities prepare. International cooperation and resilience strategies are essential as humanity faces the ever-changing face of nature's fury. The stories of Katrina, Nargis, Harvey, Haiyan, and Bola are not just tales of disaster. They are chronicles of survival, adaptation, and hope. They remind us of the awe-inspiring power of nature, the fragility of our world, and the importance of understanding the science that shapes our lives. As you ponder the drama of these incredible storms, remember, the secrets of nature are all around us, waiting to be discovered, respected, and learned from. Let's continue our journey together, exploring the mysteries and marvels of the planet we call home. Thank you for watching Nature Secrets. If you enjoyed this video, don't forget to like, share to spread the wonders of nature, and subscribe so you won't miss our next secrets.